Hello, we're the ISET2 team. My name is Pacilio.
And I'm Michaela Gerbyshak.
Our project is understanding how ocean patterns impact the coral reefs in Hawaii. This research aims to highlight the correlation between waves, ocean properties, and coral reef damage to better understand how coral systems can be preserved. Researching different ocean characteristics from the past can help to predict what will happen to coral reefs in the future.
For context, climate change has created multiple extreme changes in ocean patterns, causing excessive damage to coral reefs such as those around the Hawaiian Islands. The datasets used were sea surface temperature, chlorophyll concentrations, wave heights, sea surface salinity, bleaching alert areas, coral hotspots, and bathymetry. All metrics in this research were used to correlate with one another to understand the relationships between these patterns.
The process we used. This process uses satellite data from 2021 to map bathymetry, sea surface salinity, chlorophyll blooms, sea surface temperature, coral bleaching, alert areas, and coral hotspots. The data is focused on Oahu, and we used buoy data to calculate the average monthly wave heights. We used 4 buoys around the island. To get all different views of Oahu, we use data from the northeast, southeast, southwest, and northwest shores. This data is recorded and mapped to show the monthly differences for all of the satellites and buoys.
This video highlights chlorophyll concentrations and the graph as well. Both are to analyze the algal blooms by months in 2021. The greatest blooms were in the southeast and the northwest. Chlorophyll blooms, for context, are most frequent when the sea surface temperature is around 25 degrees Celsius. That means if it is too warm or if it is too cold, the chlorophyll will not bloom. The number of blooms drop during the summer months where the water is too warm, whereas it'll peak in the winter when the water is just right.
Sea surface temperature is the measure of the ocean's temperature. We measured the mean sea surface temperature. We also measured it in Celsius. In the winter and spring, sea surface temperatures are lower because of the cooler atmosphere, whereas in the summer and fall, sea surface temperatures tend to be higher as the weather is warmer. This correlates with chlorophyll connection concentration because the colder temperatures see the biggest spikes in chlorophyll blooms.
This graph shows wave heights around 1 p.m. in 2021 on monthly averages. There is daily data and is now averaged out. The highest wave heights were in the south of Oahu, which for reference are both in orange and green to represent southeast and southwest Oahu. This correlates with sea surface salinity because the highest sea surface salinity was in the east. The northeast saw the highest sea surface salinity because it has the least amount of water movement. That means that the salt stays in the ocean far longer than it would have in areas with more movement.
Sea surface salinity is the measure of salt throughout the sea. This affects the density and ecosystem of the ocean. The northeast tends to have the highest sea surface salinity. This is caused by less waves and a higher ocean temperature, which affects evaporation. Throughout the year, sea surface salinity continues to grow.
This video shows bleaching alert areas. In the year of 2021, Oahu saw no bleaching threat. However, in some months, other islands saw threats. For instance, in March to May, the island of Hawaii saw bleaching threats, same with other islands. Coral hotspots correlates with this because the bleaching alerts and hotspot alerts had the same months being the highest points on their graphs.
Coral hotspots are the measure of where coral has faced thermal stress. Thermal stress is heat damage. In March, hotspots hit their lowest point as the sea surface temperature also hits its lowest point. However, in August, they hit their highest as the sea surface temperature also hits its highest.
This graph highlights the bathymetry from ISAT-2. Bathymetry is the study of ocean depths, but for this research specifically, it was used to show where the coral is below the sea surface. On this graph, we can see that the data shows that the coral is about 10 meters below the sea surface on the southeast side of Oahu.
In conclusion, this research found trends between different ocean characteristics around Oahu and Hawaii.
By taking data from all four sides of Oahu, the study was able to see how different places are affected by different ocean characteristics.
This research found connections specifically between coral bleaching, sea surface temperature, wave heights, and chlorophyll.
Through this research especially, it is now possible to predict future ocean events and anomalies. This is about the pros and cons of this project. For our pros, we will bring up analyzing data, charting data, and finding motivation. Analyzing and charting data were easily the best parts because of how quick and smooth they went. If we had not had our software, we would have had to do this all by hand, which could have easily led us to go to the con side. And the final pro, finding motivation, is easily the best pro because it was so easy for us to find motivation on a topic we both were interested in.
For the cons, finding data, time limit, and scheduling. Finding data was challenging because many data sets either weren't the correct dates or were difficult to download. We were also given a time limit of 2 weeks, which created an urgency and a stress to finish this project as fast as possible and as well as possible. Scheduling was also very difficult because while working on this project, we also had other activities going on. This caused us to have a lot less time, and it made it difficult to find time to do work on the project out of what's already was scheduled. This program has helped strengthen my will to become an engineer. Through this program, I was able to connect my love for STEM with my love for my home. Dr. Simurda, thank you for guiding us through this project and nurturing our love for science. Thank you, C's, for this incredible opportunity.
This program has also helped me realize what I want to be when I grow up. I would like to continue my passion of becoming a marine biologist. Through this program, I was able to study the coral on the Hawaiian Islands, which is very interesting to me. Thank you, Dr. Simurda, for all the help that you have given us during these past few weeks, and especially thank you to C's for the summer program that is nothing like I have ever experienced.